So this lesson is supposed to be a reminder of how to factor into linear factors when basically when you have a quadratic and so here's a quadratic. This is how I know it's a quadratic because it's 2 power 2, and then you have 1 to power 1, and then you have a constant. And so this polynomial is a quadratic polynomial. And then what we want to do is to learn how to factor this without using the quadratic equation. So how do I do this? I know this is going to be equal to here the coefficient of x squared is 1, so I know this one is equal to x plus a or x plus minus a, and I can assume a is positive or negative, and x plus b. B can be positive or negative. And then this is going to be x squared plus a times x plus b times x, I'm foiling it, plus ab, which is x squared plus sum of a and b. I'm factoring x out of this and here. So I'm expecting the constant here to be that a times b and the coefficient of x to be a plus b, basically. Now, let's go about doing this. And so the choices that I have for a and b are AB, since AB is equal to 6, either I can say A is equal to 6, B is equal to 1, or the opposite, but that doesn't change a whole lot. And or I can get A to be 3, B equal to 2, or the other way around again, because here I know that the coefficient of x in the factors is 1, because this coefficient is 1, and when we're foiling, that has to be, these two have to be with coefficient 1, so it doesn't matter if I switch A and B, basically. So what I have here, it seems like I will either have x plus 6 times x plus 1, or I will have x plus 3 times x plus 2. But one of these two is very easily proven not to be correct. And which one is that? That's actually the first one, because I see A and B being 6 and 1 add up to be 7, and here A plus B is actually equal to 5. So you have to remember the constant in here. When the coefficient here is 1, the constant is A times B, and the coefficient of x is A plus B. And so the first one is not correct because 6 plus 1 is not equal to 5. And this one is correct, so I factored that into this answer. Let's do one more. Let's have x squared plus 7x plus 12 and see what happens. Again, I'm going to use that method up there. And here, A and B, let's say if it's x plus A, all of them are positive, so that is a reliable way of doing things, basically. So x plus A times x plus B, and then here A could be 12, B could be 1, A could be 6, B could be 2, A could be 4, B could be 3, and I think that's it. Now, let's see which one of A plus B makes it equal to 7. Not the first one, so the first one wrong. The second one adds up to 8, wrong. So the third one is actually the correct one. And that makes it x plus 4 times x plus 3. And you can check by foiling this, basically. If you remember, foiling it is like that, right? And then that, and this, and that, and then adding them together, basically. Now, so let's make it a little bit more complicated and see if it's still worth doing this using this method. Now, because I have a 2 in here, I know that I have to have 2x plus a times x plus b. And so 2 only factors into 2 times 1. Now it matters which order I put in A and B. But the fun part is that because this one is also a prime number. 2 was a prime number, so I had to put it with one of them. On the end was good. And then 3 is a prime number, so I will have 2 choices. Either A is equal to 3, B is equal to 1, or A is equal to 1, B is equal to 3. And you can tell that if these are not prime, it's worth actually using the quadratic equation to solve these things. But now, let's try both of them. So 2x plus 3 times x plus b. And what do I get? I get 2x squared. And then I get, oh, I'm sorry, b was 1 in his case. I'm trying the first one. And then I get 3x plus 2x plus 5x and plus 3. So that's not the answer, actually. So the next thing is, and this didn't work, and so what we need to do is to try maybe something else. So let's put a cross mark here. And let's try the second one. And the second one, 2x this time. Instead of 3, I put in 1, and then x plus 3, and I end up with 2x squared. If I'm foiling, 2x times 3 is plus 6x, and then I have x times 1, so plus 7x plus 3, and that is the correct answer in this case. So that was the factoring that we were looking for. Now, let's have one with a negative sign. And so in this case, x squared plus 4x minus 21, I can see that a times b. First of all, x squared has coefficient 1. So I can kind of switch between a and b, and that's okay. But I see a times b is equal to negative 27. So what are the choices for a and b? I can have negative 21 and 1. I can have 1. I can have 21 and negative 1 because they multiply to negative 21. I can have 3, or then I can have negative 7, or I can have negative 3 and 7. And a and b can switch, but it doesn't matter in this case. Now, what I need to check is if these two add up to negative 20, they don't add up to that. In here, again, 20, they don't. In here, they add up to negative 4, it's not. But in here, they add up to 4, which it is. And so the answer to our problem is this one.